Hey everyone. Now you may know that I recently changed ISPs to one that provides IPv6. Now the reason I wanted to do that is because I wanted to learn IPv6. Now I've been in networking for years and I know networking pretty well, but it's all been IPv4. The reason that I haven't done anything with IPv6 is because I haven't had to, and because I haven't had to, I haven't learned it, so I don't know it. But what I found out in the last few days of just getting right into it is that it's not really that hard. If you already know networking, it's still networking. So the same concepts are there. It's just a couple of new things to learn. So anyway, the last few days I've been mucking around and I set it up on my home network here. And the router that I'm using is still the Raspberry Pi. So I did everything in Linux by hand on the Raspberry Pi because that's how I like to learn things. And the best way also is packet captures, because if you want to see what it's made of, look at it. So anyway, I took some notes while I was doing it, and I'll go through now on the screen with how I set it up. Okay, I'll start off with how the setup was before I started setting up IPv6 properly. So if I just look at the addresses on the interface, just do IP address, you see my IPv4 address and there's some IPv6 address, okay? Now first of all, if I do -6 from now on, I'll only show the IPv6 stuff. So that's what I'm going to do from now on. So this address here, there is one here for IPv6, but it says scope link. That just means that it's not going to route anywhere. It's only good for traffic on its own little link here. So other computers on my same VLAN around the house here, that'll work fine. So that was self-generated from the MAC address. If I show you the MAC address, you can see this 270, it looks like up here, 38. You can see it there, and for these link local, it always puts this FFFE in the middle of them. So it's basically my MAC address with FFFE in the middle. So that's that. So let's say I go to a different computer. Let's go to a Raspberry Pi that's outside, and I'll have a look at what it's got. So it's got the same kind of thing. It's got a link address here. So there it is there. I'm going to copy that address. Then I'm going to exit out of that back here. I'm going to ping that. And there it is. Now I ping that fine, but you can see here, it's added a little bit of something to it. It's added the interface name. So my interface on this computer here is called EMP3SO, and it added that onto the address. So what I really could have done is %EMP3SO to tell it which adapter to use. Now the reason I might need that is because, like on my router, if I do, IPv6 address, and I'll just include the link stuff, you can see that these are all my VLAN interfaces that I've got on the router for various subnets and that, but they all have a link address and it's all the same. So if I went to, like before, ping that Raspberry Pi outside, it wouldn't know what to do. So I'll just do it again, just like that. And it says, there you go, invalid argument, because it doesn't know which one to use. So, and EVE0, just EVE0, that's the one. So there it is. So that's the link address. So you can use that. You're probably on your own system now, even though you've never really thought about it. You can do that. So back here, even though I can ping that address, if I try to SSH it, it says invalid argument, because even though the ping figured out that there's only one interface that could go out, the SSH wanted a bit more specific. So I don't know, what was it? EMP3SO. So now, oh, hang on. Pi at that. There, I'm in. So there you go. That's using link addresses. If I say who's connected, oh, that's an old one. It shows that I'm connected from this link address. So that's that. Now I'm going to get into the real IPv6 stuff that'll get out to the world, because those link addresses won't go through any router. They're just for local stuff, as I said. So if I start off with my router. Okay, that's where all my routing is going to happen. And I'll just draw another router, which is my ISP's router. Okay, and I'll get all fancy and I'll label them. So that's ISP router, and that's my router. Okay, so I've got my router here, and that of course goes into a switch, and then I've got a whole bunch of hosts around the house. So, you know, just random hosts. Host, I won't bore you with the details. Actually, yes, I will. Fuck it. Host, 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 host. Okay, so these are various computers around the house. So on my router, I've still got my LAN side and my WAN side. So this is my LAN and that's my WAN. Now my router got an IP address from the ISP, and I'll have a look at that. Okay, so on the router, IPv6 address show device if02, which is my WAN interface. You can see, like before, I've got this this link address. So the scope of it, meaning where it's valid, the scope is just the link, and they always start with FE80, by the way. But now I've got this other one. I've got this global one here, scope global. That's good for the world, and that's the big long one. And they're both 128 bits. It's just that where you see these double colons, it just means there's all zeros in between there to fill it up, so you don't have to write all the zeros in there. That's all. But anyway, 128 bits, and there's my WAN address. So how did I get that from the ISP? Well, what happens is these things called router advertisements. Router advertisement. Okay, or just RA for router advertisement. So the router out there, the ISP, sends these router advertisements. And my router's, what's it going to do? I'm going to look at them. So what I'm going to send out is things called router, this is a stupid word, but solicitation, or RS. So what that means basically is it's asking for something. It's looking for a router. It's soliciting for a router action. So it's saying, hey, is there a router there? And the router out there sends ads saying, yes, I'm a router. At this point, my router is just like a client host. Okay, it doesn't know that it's really a router yet, but we'll get to that. So I'm looking for a router from the ISP, and the ISP's router is advertising it. Okay, so it's an ICMP message, version 6, of course. And it's got a couple of flags and a bit of stuff. So you can see it's giving out its MAC address here and the MTU. You can see where it came from though. Its source, when I find it, is there. Begins with FE80, which remember was a link address. So that's the link between me and the ISP. It's telling me its link address, and it's saying that it's a router. Now it's also saying that there's some managed stuff. So I'll get to that in a minute. Well, actually, I'll get to it now. Okay, so this managed flag that's set here means it tells the client, which is my router, to get an address from a DHCP 6 server. So that it can get an address from this using Slack, which is stateless address auto configuration. But when that managed flag's set, it says, hey, go get it from a DHCP server. So because that's set, my client, my router's WAN side, would have gone off to a DHCP server. So I'll see if I got some of that. Okay, and here's how that looks. So it's been online, so it's just a renew that it does every now and again. But you can see what's in it. So my client identifier goes out, and that's what's used for any reservations and stuff. The DHCP v6 doesn't use MAC addresses. It uses this unique thing here, which are generated differently on different hosts. So I just packet capture it to find out what it is. Anyway, there's my client identifier, the server identifier, blah, blah, blah. A bit of time, vendor, yeah. There's my DHCP client. What else we got? Non-temporary address. So that's the address. So there's my WAN address, the one that you saw on my router. That's what was given to me by the ISP via DHCP, not Slack. Okay, and the other thing that comes in is my prefix. So this is the /48 that's been given to me to use how I want. So given that there's 128 bits in an IP6 address, that if they begin with this first 48, they're mine. That leaves me 80 bits to do whatever I want with, which is just insane. So anyway, that's what I've got. And that was given to me as an option. These are all DHCP options, and that was given to me by the ISP. Now, the rest is just other stuff, which I won't get into. This is a bit wrong because my name's just router, but on the real world, it's not just router. That's why it came back and had a bit of a sook. It said, come on, you can't be called router. But anyway, that doesn't matter for now. The fact is it gets its IP address from a DHCP server because the stateless method told it that it was managed, so go get a DHCP server. If that managed flag wasn't set in the Slack router advertisement, it wouldn't have tried to do DHCP. So anyway, it did DHCP, used my unique identifier, got an address, and importantly, it told me my prefix delegation. This was given to me by the ISP. And one thing I found out too, the hard way, but I figured it out easy enough, I suppose, is this is UDP. So like DHCP4 uses UDP ports 67 and 68. This uses 546 and 547. So when I ask for stuff from the DHCP server and it gives me something, I have to allow that UDP port 546 back in through my firewall, otherwise it wouldn't work. Now, I initially didn't have that set because I thought, it's the same session, same kind of thing. But the thing is, the transmission, its destination was a multicast address. So when it comes back, it's kind of a different socket. So it didn't see that as the same connection. So I had to specifically allow that UDP port back in. But anyway, that's how my router gets its address. So back on my router, in my ETC interfaces, I've got this set. So for the WAN, which is my interface ETH02, which is my VLAN 2 that goes out from my little SFP modem, I'm telling that for INET 6 to get it from DHCP. Now this here, request prefix, is requesting that those prefixes I showed you. So if I go back here, you see the prefix that I talked about. Where is it? The prefix delegation. I requested that. So that's me requesting that, saying yes. And I also have to accept router advertisements. So to actually accept what they're giving me, so just because their router's sending out all these RAs doesn't mean I have to accept them. But in my config, I'm saying accept them. And the reason it's 2 instead of 1 is because my router, my Raspberry Pi, is going to be an actual router, I need to set that to 2, because if I just set that to 1, it wouldn't be routing them. So I have to set that to 2 to receive an IP address from that and also be part of a router. So the other thing I had to do was in sysctl, I had to set forwarding for the router to be a router, similar to like you do in IPv4. I had to set the forwarding to 1 to allow my router to be a router for IPv6. So we're getting there bit by bit now. The next thing I had to do was set an IP address on my LAN side. So one of the VLANs I've got is IP-6 address show device ETH0.100, like my VLAN 100. And what I've done is I've just set an address manually to be, where is it? This one. I set that manually on my LAN side on one of the VLANs. So what I did, I used that same 48-bit prefix and I just put 100 for the next one because I'm just calling this VLAN 100, so I'm using just 100 as the addressing scheme. And this /64 is these 64 bits here. So there's my network, and the rest, remember this fills in for all the zeros to make up the leading zeros, and I just use FE on the end. The reason I did that is because it's 254 and that was kind of what I'm used to, but I might change that. So that's the LAN address. So on the config for my network for the LAN side, I just set it to be okay, ETH0.100, which is VLAN 100. Tell it to be a static address, and the address is that. So that's where I set the address on my LAN side. So we're getting there. So now I've got my IP set up out here, which was given to me by the DHCP server at the ISP, because the managed flag was set. Managed, right, which says go and get DHCP. That came in and the WAN bit's done. I also, as part of that DHCP request, requested my prefix, and by doing that it tells the ISP to route all the stuff to me as well, so it knows I'm using it. So that prefix came down here. So then I set my IP address on the LAN side just manually, so that never changes, and that's it. So that's what I've done so far. So what I need to do now is I need to do something similar for all these hosts out here in my network so that they can get a real IPv6 address too, because with that link address they can't really get out of this this local area here. So I have to get them an address. So what I did, the router at the ISP was giving me these router advertisements. So what I need to do is get my router to also send RAs. I need it to send router advertisements to my host here so that they know there's a router there. And just similar, it could give out an IP address itself using Slack, or I could run my own DHCP server, which is what I ended up doing, DHCP. So for these router advertisements, I'll show you how I did that. So back in my router, there's a program called RADVD, which is just router advertisement daemon. And a bit of config for it. I'll just show you my Ethernet 100. Here's my config. So for Ethernet 0-100, for VLAN 100, this prefix would have set out automatic addresses for my network, but I'm going to set them by DHCP, so I've commented that out. But the main thing to know here is that I'm sending out adverts saying, yeah, send ads out, and I've also set that managed flag. So these clients on my network, or my hosts, will see that it's managed for their IP address, and then they'll go looking for a DHCP server. So bash service RADVD start. Okay, so if I look at this now, I've still got no address, because if you remember, I was just doing a packet capture then, and I can show you, I'll forget all that crap, just pick one of these. You remember that I had the flag set to be managed. Okay, I'm not giving an address from this. I can, but I'm not, because I remarked out all those prefix things for my network. So I'm just saying, yep, there's a router here, but go get your address from a DHCP server, which I haven't set up yet. So in here, I've still only got the link address. However, I do have a route. So here, even though I can't really use it for much, I have a default route now using a link local address. You can tell because the FE80, and also you can see that it came in via a router advertisement. So what I will do now is I'll show you the DHCP server, which is on my router. So DHCP, and I'm using the ISC DHCP server, but you have to run a separate instance of it. So anyway, okay, so here's a bit of the config for the DHCP 6 server. I'll use the same VLAN that I was using before, which is VLAN 100. Now, as you know, those 64 bits there are now the network portion because of this /64, and the rest is, well, that's just open for addresses. So I'm giving it the range, which is 1 to F0. That could be huge though. And again, these double colons are just all zeros to fill in between. And I'm also giving it a DHCP option, telling it my name server, my DNS server, and I'm pointing that to, that's just my router running Pi-hole. And here I've got a host specific address. So in the old DHCP, you could reserve an IP address for a particular MAC address, but IPv6 DHCP doesn't use MAC addresses. They use this client identifier, and it's bloody long, and there's a few ways to work them out. But what I did, I just cheated in the DHCP request and looked at it in Wireshark and just grabbed whatever it was sending out and used that for the reservation. And now I'm giving it a fixed address, obviously the same start, and I'm just calling it 50. Actually, I'll just come back to this VLAN where I've got just a couple of hosts set up for now. And this desktop that I'm on here, using this host identifier, again, that I got from a packet capture, I'm telling it to use that address. So for this one, it's just 1 instead of 100. But the same thing, that's the 64 bits of the network, and this is the host here, as determined by the fact that it's a /64. So what I'll do, I'll go DHCPD version 6, config file DHCPD 6, and that's running there. So now, if I come back to this desktop, if I go to the settings and just piss that off, start again, you should see it ask for a DHCP 6 address now. So there it is. So it's solicited, same as before, it solicits and then it gets advertised. So for the solicitation, that's my computer, and this is what I copied before. This client identifier, this big long thing here, 67448, that's what I used in the router to set the IP reservation. So anyway, look at the address now, and I've got this address, the one that was given out from my DHCP config, and now it's global. So I can ping something out in the world, and it uses IPv6. So there it is. Again, packet captures are the only way to go. So this host sent out a router solicitation looking for a router. This sent back a router advertisement saying, yeah, I'm a router, and we add that to my routing table for a default route. And also as part of that, it had the managed flag set, which tells this to go then to a DHCP server. This is where I had all my DHCP options, including the address and the DNS server, and that came back and that put that in there. So after all that, I I've got a functioning IPv6 network. Now I've got to look at the firewall on the router here. So I'll just show you a portion of it. This is for my WAN interface, which is ETH02. So this says things coming in. The input interface name is my WAN interface. If it's a connection that's already established or related, then accept that. Now this has been like that since day one, even in the old stuff, because that just allows you return traffic back like always. Another one is OpenVPN, because I've got a VPN server, even though you have to have the right encrypted initial packet or it'll just get dropped at a higher layer. Anyway, that's my VPN input. And this is the one I said I had to let back in for the DHCP version 6. So if the source port is 547, the destination port is 546, accept it. If that's not in there, I won't get my prefix delegation from the ISP and other stuff. So that has to be there for DHCP to work. The other one I've got is to allow some things. So, I didn't talk about neighbors. I'll get to that in a sec. The router solicit, probably don't have to have that since that's coming from the ISP to me, but I definitely need their router advertisements allowed in. This is multicast listeners, which I've still got to research a bit about, but I know it's got to be there, maybe, so I'll check that too. And these two are just to find neighbors. I forgot to mention that, so let's, I'll show you that. What I'll do is I'll just go to my piano and I'll get its link local because I haven't done anything with this just yet, so I'll get a fresh one there. Come back here. Now I'm about to ping the piano. So I'll just start packet capture looking at IPv6. Now I'll ping it. And what happened, just before the ping, there's the ping request and reply, but it did this now neighbor solicitation. Think of that kind of like an ARP request and ARP response. But it's not a broadcast, it's a multicast. So it only goes to the machines that want multicast. So the idea being it doesn't broadcast everywhere over the network, even though it still gets around pretty far. So that neighbor solicitation and neighbor advertisement is kind of like ARP. It's so it can find out which MAC address we're actually sending this to. And there's the actual ping. So let's go back to the router. So in that thing I had a second ago with my firewall rules, that's the neighbor solicit and neighbor advertisement. Everything else, drop. Now I don't have any firewall rules on the outgoing yet, but I will. I just haven't done that yet because I haven't put all my smart stuff on there. If they can do IPv6, I'm yet to find out. But anyway, that's the basic setup of how I got this going at home. Right, down in this little corner of the garage, I've just set up a test Aruba AP, just a little instant here, using IPv6 only. There's no IPv4 address on that. And I just set a SSID up for that to test it with a laptop. And I also, if you remember my classic little multicast TV servers, I set this up as well on IPv6, streaming out using DV Blast on IPv6, just for a test. That's why these things are handy, not to watch TV, just to test stuff. So I'll show you how that looks. Okay, so this is that Raspberry Pi, and I'm just going to stream channel 10, and you can see the address I'm sending it to is FF08, which is a multicast address, and just one. I don't know if that's the right multicast address to use. I've got to look into that more, because I know with IPv4, there were specific groups for specific purposes. But anyway, I don't think that's the right address to use because I think that's on all nodes if I'm right, but don't quote me on that. Either way, it is multicast. So what I'm going to do is just stream that out. So that's DV Blast there. And I'm going to open it up just like that and see what happens. So something's coming up. Oh, chick in the background. Okay, it's a bit rough. I'm thinking it's a bit rough because I might not have unicast optimization on there, or the reception coming in might be bad. I don't know. But fundamentally it works. I've just got to clean up that. But that was a very quick test anyway to see if it works, which it does. Right, so I'll just log into that AP. Now here's the address, but I can't just do that because given that it's full of colons, it can't tell where the address ends and where a port begins because you use colon for port. So you've got to put the square brackets around it, and it's port 4. Actually, I'll just do that. So HTTP, that. Okay, now that'll redirect to port 4343, so you'll see that. So you can see now it's got a colon there for 4343, and the usual cert bypass thingamajig here. So I'll just log in really quickly, and you'll see that the AP doesn't have that's the link address for IPv4. It doesn't have a real IPv4 address. It does have an IPv6 address though, which is what I just logged into. And there's a client on here, which is that laptop. Now you can see that the laptop doesn't have any IPv4 address because I disabled the IPv4 DHCP server. I'm just using its version 6 address, and it works as normal. So that's that. Right, now here's something I found, and I found it disappointing. So what I did is I disabled IPv4 off the network. So I've only got an IPv6 host here. And what I found is that a lot of sites don't work. Now Google does, DuckDuckGo doesn't. Facebook does, BOM doesn't. BOM's our Bureau of Meteorology. A couple of random sites did work. These interesting, whatever they are. Speed test didn't. Now that really surprised me. I would have thought they would work, but that doesn't work. Some were a bit half and half, like this one here. You can see it's got some components that loaded and some didn't. So it's like a half and half site. Tutor does, obviously. I'd be surprised if that didn't. Twitter doesn't. I mean, Twitter doesn't. These are supposed to be the big Silicon Valley, and Debian isn't, which surprised me. But all the Linux nerdy stuff does. Like if I do apt-get updates, they work. So that's that. But some of these really surprised me, and I have my theories on that. Also, Microsoft Teams doesn't even work. So Microsoft doesn't work, and that goes for Skype as well. That doesn't work either. Now, the reason they came up with IPv6 in the first place is because we run out of IPv4 addresses. So you know it's very hard to get a public IPv4 address these days. And given that not many ISPs provide IPv6, it's also very hard to get a public IPv6 address as well. So you're kind of subservient to some sort of cloud service to access stuff, where really all your networks, all your hosts could be accessible anywhere in the world with IPv6, but you're going to have to keep using someone else's public IP address and go through them, and no doubt cost money. So I am a bit surprised that some of the big tech companies like Twitter, I mean, I don't call that tech as such, it's just something that's gotten big and they call it big in the tech, but the tech stuff is the nerdy stuff as far as I'm concerned. But they're called big tech, and other than Google and Facebook, there's a lot that aren't really there for IPv6. So if they're not doing it, we're going to struggle with this. And one thing I found is in the last few days that I've been playing with this from scratch, I'm already frustrated with the uptake of this because it's really not that hard. If you know networking already, this is just another aspect of it, you know. If we didn't tell you it was a brand new protocol, you would have just learned it along the way anyway. But I think there was that apprehension of learning something new and scary because it's got big addresses. Those addresses make more sense because the hex is mapped to the bits that it represents, because at the end of the day, it's just bits. It's 128 as opposed to 32, and they're just represented with hex characters, which it directly maps. It's actually easier, I think. After a few days, I started being able to recognize, oh, that's that. So anyway, I'm new at this. It's going okay from my perspective, from the technical side of things. Just I'm now seeing the problems with the world taking it up, and I think it's about time they got on board. So anyway, that'll do for now. Till next time, take it easy.